So we are in chapter 3 now. And I got to say that chapter 3 is kind of like the oddball chapter because we're not going to be doing GeoGebra. We're not going to be doing any real statistics. It's just probability. We're going to get through it. It's a lot of by hand. And what I have up right now on the side is Desmos. I don't know. I've probably shown you all Desmos a couple times. Just a scientific calculator, you know. So I want to do some math in that. It'll be like multiplying and adding and stuff as we go. So here, we got to fill in the pieces here, right? Let me flip to the page and fill in some words that probably won't mean much in the end. We have experiment. Ooh, ah. We have trial. Oh, y'all aren't doing it. I'm doing it for you. We have outcome. Okay. I got sample space, and then I have event. And so, obviously, y'all can read if you want to, but in the end, a single trial is something that happened, and we will look for the outcome. That's kind of like the end result, I guess you could say. Sample space is everything that we've ever done. One event is a single part of that. So there you go. Blah, 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 blah. Where's the math, right? Let's go and do it. So does anybody, I could wait and pause for a second, though, if y'all are copying down some cool words. Okay. Good. 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 I'm not worried about this stuff. You shouldn't be worried about this stuff. All right. Now I'm all of a sudden worried about this stuff. A university is trying to determine if a certain remedial class is needed to be offered for incoming class. Each student gives the same exam. If they score 75, they'll be recommended for this. So identify all this stuff. And so if you can see here, there's like 2 experiment, 2 trial, and 2 outcome. So it's kind of like true false, but there's like 3 of them at once. Okay. So we got to click one of those, one of those, one of those. So an experiment is identifying whether the student is getting less than this or that, or an experiment is giving the exam. I think that's going to be the giving of the exam. We can go back up and verify right quick. Is an action through which specific results are obtained. That's so clear, isn't it? Hello. It's just so clear. Would you say then the experiment is identifying blah or giving the exam then? Y'all help me. The exam? You think B? Okay, part B. Okay. A trial is a student scoring 75 or less, or a trial is one exam being taken. One exam. Yep, a single thing. An outcome is scoring 80%, or an outcome is a student taking the exam. Yeah, the 80%. Yeah. If you see outcome is the result of it. Yeah. Correct. That's it. Just one piece of data. Yep. Cool. And we'll never see it again, literally. So, last chance. Now we're going to do math. Okay. So, probability. So probability is how what's the probability of something happening, right? And we got like chance of rain. What's the probability of flipping a coin, that kind of thing. And so that's what we're going to start working with here are just numbers. And so it doesn't look like there's any numbers, but there is here. Okay. So determining a favorite steak, we have the cut. Would that be the cut? And then there's the doneness. Yeah. And so they're wanting to see what the sample space is, and therefore I can also find out what's the probability of me getting you like a correct answer. If I'm guessing, what's the probability of me being right? Does that make sense? So here we go. I got ribeye, I got filet, I got T-bone, and I got sirloin. But for each one of those, I could either have it rare, medium, or well done, or something in between for a lot of us. Rare, medium, well done, right? I'm kind of running out of room here. Rare, medium, well done, and then finally rare, medium, well done. So in a way, I'm going to ask how many actual outcomes are possible here. 12, because I got ribeye rare, ribeye medium, ribeye well. There's 3, right? And then the 3, 3, and 3, you add them all up, you get 12. You're right. There we go. So 12 possibilities, I guess you could say. Possibilities. So I'm going to ask now, if I'm just simply guessing, what's the probability of me getting your favorite steak correct. I'm guessing one time. There's 12 possibilities. What's the probability then? 1 in 12, exactly. 1 out of 12, exactly. See, and that's how we're going to be seeing this as we keep going. This is me, one guess, and I got 12 total, I guess you could say. 12 total options. Yeah. So 1 out of 12, exactly. All right, cool. So far, so good? Let's keep going. Any questions on that, though? Hello. Okay, I'm going to keep cruising then. So fundamental counting principle, blah, 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 blah. Right here's the most important thing. We are going to multiply when we get two different things going on. And we kind of already did that earlier. If you go back, I have 4 of these guys, right? And I've got 3 of these guys. How did I get to 12? I wonder. I multiplied, right? Does that make sense? So that's what I'm going to do here. Multiply. Blah, 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 multiply. So a popular brand of pen has 9 colors and 5 tips. How many different pens we got? How many? 45? 45? You're right. No, it's good. It's good. 45 different pens. There you go. That is the math we're doing today. Sounds pretty good, right? Of course, there's going to be little things here and there we're going to learn. I want to see if y'all can get these now. So we got a restaurant's is offering a limited lunch menu. We got main course, vegetables, all this stuff here. How many different things can you do if you're ordering one of each? So how many options do we have on the main course? And then 4, and then what do I do with these numbers? Multiply. Yep, multiply. 3 times 4 times 5 times the 2. 120. 120 different ways. Awesome. So, pretty straightforward. I'm going to tell you a small key word before we keep going. If you ever use the word and in some kind of logic that we're using here, you're going to want to multiply. If you ever see the word or, you're going to want to add. And so here, it's kind of an interesting thing. I have ham, chicken, or fish. Okay, so I did 1 plus 1 plus 1 is 3, right? So that's easy. But then I'm picking a main course and a vegetable, right? So that's where that and between these two, and means to multiply. Beverage and a beverage and a dessert. Cool? We'll be seeing that more as we keep going, and I'll be reminding you as we keep going. So and mean multiply, or is add. Cool? Easy math so far, right? It will get a little bit more later, but for now, yeah. So access code for a car security system. We have 4 different digits. The first digit cannot be 6 for some reason, and then the last digit must be odd. Again, for some reason. How many different codes are possible? So what I like to do is I like to physically draw out whatever I have. So I'm going to have like the 4 different things. Just for example, 1, 2, 3, 4, right? But now I can't use that because the last one was the odd. So 1, 2, 3, 3. 1, 2, 3, 5. I got 2, 3, 5, 7. Like I can keep going forever, right? How many different codes do we got? So how about this? It says cannot be 6. So what numbers, what digits are not 6? Give me some. 1, 2, 5, 0. I heard it. 0, right? 0 is a digit still, right? You could go 0, 0, 0, 1, I guess would kind of work in this case here. So all these other ones, we got 0 through 9, 0 through 9. And then this guy, the odds are only 7, 9. So how many possibles do we have for this guy right here? How many digits can I use for this? Count them up. 9. Yep. How many for this one, though? 10, 10, and then 5. Only 5 digits there. So again, thinking about the logic for a second, I'm going to press the first button, and then I'm going to press the second button, and then the third button, and then the fourth button, and. So what do I do with these numbers? Multiply, exactly. You got it. I think that comes out to what, 4,500? I think so. Because like those are zeros, and there's 45, so there you go. Total, I guess. I don't know, something like that. Cool. Making sense? And means multiply. Let's keep going, I guess, unless y'all want me to stop and pause. Okay. So, how many different license plates can you make if it's 6 letters, each of which can be repeated? So, okay, 6 letters. We got, and then we got like the dash. Hold on. Nope. Not here in Texas. We ain't got no dash. What do we got in the middle here? Have you overlooked at the license plates? Huh? Nope. It's a little Texas. Yep, it's a little Texas here. Yep. Yeah, I'm gonna do it. I'm gonna do it. Okay, here we go. It's a little tiny Texas. Yeah. So yeah, I know. Oh yeah. Okay, so I got a little tiny Texas in there. So 6 different letters. How many options would I have for this position? 26. Yes, exactly. Because I can repeat them. Ooh. 26, 26, 26. So then let's do the math a little easier. I'm going to use the calculator here. I can do 26 times 26 times 26, right? That would take forever. There it is. What's the power? 6 total. Yep, 6 total. You got it. So 26 to the 6th power. Do not try to do this at home. It'll probably want you to type that huge number. Yeah, I know. Welcome to Newton Alta. So, okay. Maybe. I haven't tried that. It's a possibility. Okay, cool. So, what if they cannot be repeated? So that's a little different, isn't it? There it is. You got it. Yes, 26. And then because I used the letter A already, now I only have 25 left. Then I used B, so now I got 24 left. Does that make sense? 22, 21. Now, there's not a really great way to do that besides just simply multiply it. So here we go, 26, 25, 24, 23, 22, 21. So obviously it will be less because we're taking away a lot of options. There we go. Cool. So you're wondering, can I still make that license plate? Oh, yeah, you know what I'm going to do? I've always wanted this one. Cool dude. It's like, no, dude, that's cold dud. Anyways. I know, I'm just being silly here. So, you good? Okay. So, not too bad. This is kind of like a hard break here. So, we've been talking about how to count up totals, and I kind of hinted at the probability. Now we're actually going to be using it now. Classical probability is when we use things like cards, dice, coins, and other things kind of like that. Things that we've had literally forever. So they're static; they don't change. We all know, and how it works. So that's classical. So the probability, this is the formula for it, but I really don't like this. What I would prefer is, actually, let me get a little bit more room over here. I'm going to say probability, my formula, is selected over total. Selected over total. And I will use that so many times through chapter 3 because I'm going to physically select some objects from a total. We count them up and we're done. Okay. Probability's got to be from 0 to 1, which again means 0% all the way to 100%. So whenever you get probability of rain, it stops at 100, right? Hopefully. Well, actually, not hopefully. Now we could probably need some. So the probability of an experiment consisting of a 6-sided dice, classic, right? Dice, classical. Find the probability of rolling a number that's less than 4. Okay, so what could I get on a dice? What values are possible out of this thing? 1 through 6. So let me say 1, 2, 3, 4, 5, 6. These are the possible outcomes, I guess you could say. And I want to select the ones that they're looking for. So rolling a number that's less than 4. So what's less than 4? 3, 2, and 1. These guys right here, right? So yes, my probability, I have 3 selected and 6 total. When I reduce that down, 1/2, yep, I like that. And because they say decimals and stuff, 0.5, very good. That's a good question. They actually will sometimes have that on the homework, but whenever they do, it'll have a little percent sign next to it, and that's when you put 50 in there. Very good. Thank you for mentioning that. Yes. So yeah, selected over total. And again, this is an easy one. I just wanted to make sure we could see the format and the style. Oh yes. Oh yeah, they're gonna all over the place here. Yep. That's Newton. Not very consistent. In fact, it's kind of silly. They'll have 3 on one on another, 2 decimals on another one. It's just all over the place. So yeah, it's just I don't know. Cards. I mean, are y'all okay with this? Okay, cool. Cards. Who in here knows cards pretty well? Cards. That's good enough. You got it, man. You're the professional here now. So yeah, cards. If you know anything about cards, this is kind of what all the cards would be laid out. We have 4 different suits, 2 different colors, and then 52 total cards individually, right? So using this, we're gonna get, I guess the points from this here. We're gonna get the answers from this. So it says selecting a 9 of clubs. So 9 of clubs, right there. Yeah. So I'm looking for probability. There it is. 1 selected over the 52 total. Very good. Fraction. When it comes to cards, fractions. Yep. No, they won't. They will not. They want fractions on these guys. I know. Let's do another one. Are y'all so far? Is that okay? Clubs, right? Yep. It'll end up a fraction, I think. So yeah, hearts. Hearts are like all of these cards, yeah? There you go. There you go. And yes, yes, yes. If you know the answer, you can cut to the end. You already know what's going on. I'm totally fine with that. The long way is 13 are selected out of the 52, but you already know the answer now. It's going to be, yeah, 25%, 1/4. Yep, exactly. And you can just look at it and say, well, there's 1 suit out of 4 suits that are selected. That's another way we can easily go about doing that. Last one is a diamond, club, heart, or a spade. Yeah, I guess. Wow. Okay. So yeah, 52 out of 52 is just 100%. Yeah, that's just weird. But we did it. So they will ask card questions on your homework, and so you can always come back to this for as like a guide if you don't know what's going on. You could just buy a deck of cards. I recommend the bicycle ones. It's just a joke. It's just name brand. I'm sorry. I'm not endorsing bicycle cards any more than the Bumblebees. Okay. Moving on. I'm not getting paid for this. So, all right. 12-sided die. What does that look like? It kind of looks like a big circle thing, but with numbers 1 through 12. There you go. So find the probability of rolling a number that's greater than 2. What's greater than 2? 3 through 12. You could see that I'm literally physically selecting these every single time. So then how many did I select? 10 out of, perfect. And so when I reduce it down, very good. If you're ever wondering like how can I get that on the calculator, Desmos will do it for you. You can just click the little fraction button. So sometimes it'll be more complicated. We can just use the calculator, you know what I mean? Cool? Okay. I feel like I'm going really fast, but I mean, if y'all are okay with this, then I'm okay with this. Y'all just want to leave early, I see. So a fair 2-sided coin is flipped. By fair, they just mean it's actually 50-50, I know some coins are bent. I don't know if y'all have ever seen an unfair coin. They might talk about that on the homework, and they'll tell you this coin is only 30% chance of something because they bent it so that it flips a certain way. I don't know. So just watch out for those kind of things. So fair means 50-50. So we're flipping coins, and they say we want to get at least 2 tails. At least 2 tails. So 2 would be the least. Could I have 3? Could I have 4? Could I have 1? No. So 2 tails, 3 tails, or 4 tails. All of those are fine. So I'm looking for at least 2. Does this have at least 2 tails? No. What about this guy? What about this one? And then no, yes, 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 no, yes, 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 yes. I'm getting lazy. But notice that again, I'm physically selecting them, right? Physically selecting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my probability would be 11. There you go. You got it. Now that does not reduce. You could go and check it on the calculator, but that's basically it. Oh, look, simplified fraction. There you go. Yay. Cool. You roll a pair of 4-sided dice. They kind of look like triangle things. And then you record the sum, list all the possible sums, and then what's the probability of a 7. Do we have more room? Okay. So they have 2 different dice triangle thingies. And so let's do blue and red. Okay. So I'm going to do 2 different kinds. This will be my reds, and this will be my blues. Writing it all in green, I guess. 1, 2, 3, 4. 1, 2, 3, 4. And they're saying they were looking for the sum, as in they add it up. So what if you had a 1 and a 1? You would get a perfect. A 1 and a 2 would make a exactly 4, 5. 3, 4, 5, 6, 7. Perfect, perfect. So those are the possible outcomes. They're asking now for what's the probability of a 7? Yep, right here. There's 2 of them right there. Very good. See, again, I'm physically selecting them. I cannot stress that enough. We have to physically select them. So I got 2 selected out of how many total? There you go. 16 total. 4 times 4 is 16, essentially. So 1/8, and you're done. Cool, cool, cool. Okay. So I keep saying physically select them. So let's say you're taking an exam, and you're in the math lab, and you want to like do what I'm doing here. You want to draw on top of it. You get your pencil and you draw on top of it. Okay. The monitor will be fine. I've done it here. Oh, I'm being recorded. And I do it up in my office. Sometimes, like office hours, they come by, and I start drawing on my monitor. People are freaking out, but it works because you erase. Okay, physically select them. I'm super serious. Okay, whatever it takes. I want you to pass my class, even if you draw on a monitor. Moving on. So it's okay. You're not getting kicked out. Secondary school uniform. We got all these different options here, and so they're showing all the options in this. I gotta say, if you notice the font, this is a direct copy paste from Newton. Okay, so this is your homework, copy pasted. It will look just like this with these pictures. What's the probability of a student who chooses plaid skirt and black sneakers? So plaid skirt and black sneakers. Okay, black sneakers. Oh, here we go. Plaid skirt. Yep, got it. 2, because they still have to pick a polo, apparently, right? So in the end, it's not what I just circled. It's like these 2 that I'm really selecting. Yeah. So these 2 right here, 2 selected. What's my total? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep. Total. There it is. 1/8. You got it. Sweet. Cool. On these questions, yes. There's other ones like this with restaurants, I think, and hardware stores. Very weird. So, yes, you will see the tree just like this. So here's another tree. This one's different. It has these little probability lines here, but we're going to get through it. Kevin is hiring 2 interns. All applicants have reading and whatever. Here's a tree. So based on this tree, hiring 2 interns from reading. So I guess reading is just R. 2 interns, as in both. So you can see that we got, what is the other one? Beekman. So Beekman, Reed, Beekman, Reed, Beekman. Isn't it this one? Right, this branch basically, because it was Reed to get there. No, you don't like this. You're like, no, you don't like it. Isn't it reading? 2 interns from reading, right? 2 from reading. So that would be, I had the first one reading, and then I had the second one reading. R means reading. Yeah, B means beakman, I guess. So yeah, RR, reading, reading. And so I would think, just between you and me, I got 1 out of 4, just like what we just did a second ago, right? But it's not that way. I have to kind of look at what's going on here. Now, if you look at these two between them, wouldn't I get 100% total between these guys, right? 7 plus 4 is 11. So when I'm saying I would either get a Reed or a Beekman, so those are the 2 options here. Again, you can see all of these would add up to 100% between them, right? So I'm going to take this guy. Okay, so that's the probability of getting reading, right? You got me? You got me? And then I get another one. Multiply. There it is. Exactly. The and means to multiply. So this guy and this guy, here we go. So I got a 4 out of 11 and 3 out of 10. In the word, I'm going to use the word and. And means to multiply. That's what I'm doing. And I'm going to use a calculator because I don't know all this stuff personally. Fraction action. And there we go. So 6 out of 55. I know that's kind of strange, but it's not that we're having reading or reading, right? It's reading and reading. There's got to be this 2 right there. Is that one okay for y'all? That one's a little bit left field. I think that's a new one because, yeah, the old workbook I had the grocery store, hardware store thing that I was talking about. So, yeah, this one's a new one for me. But, yeah, I would multiply. Cool, cool. Any questions? Moving on. Oh, there it is. Look at that. It's on the next page. So we got grocery store, pet store, restaurant, blah, blah, blah. What's the probability of a group of stores that will have restaurant or hardware store or both? Right? So, yeah, we're going to be adding, exactly. So let's understand how this will work. I got restaurant or a hardware store or both. So I'm going to look for anything that has a hardware store. Let's start. No, restaurant. So no restaurant here. This has a restaurant. Both of these actually have a restaurant, don't they? So what I'm going to do is I'm going to select both of them because they both have a restaurant eventually. Okay. No restaurant over there. Okay. Or, so I'm going to add now to my selection. Here, I'm going to use a different color for my selection. Okay. So I already did that one. Now I'm going to do the hardware. Hardware. Yes. Okay, cool. Whoa, Chad. You selected him twice. I know, but like I don't think I'm going to count him twice. I'm just making sure that he's definitely selected. Okay. Is that okay? Well, we probably won't. See, like if I start grouping people and I count people twice, that would be bias, I suppose. I'm gonna yeah. This is a good question though. Good. Or both. And so I'm looking for hardware and restaurant. That would be like that guy again, I guess, right? Because he would have the restaurant and the hardware. And so looking out, zooming out, I'm simply looking at who got selected. How many actually got selected? 4. 4 got selected. I know he got selected 3 times, but like it doesn't really matter. Did he get selected? Yes. What's my total? 6. So my probability? 2 out of 3. Yep, 2 out of 3. Cool. Does that make sense? Good. You might get selected multiple times. Doesn't matter. I'm just saying, did you get selected? And you would say yes or no, count them, moving on. Cool? Okay, hard break, because this one right here is a new piece, a new section. Empirical probability is whenever they're, here, I'm going to just put Chad definition. Charts, graphs, data, statistics, I don't know, stuff like this. It's just, yeah, that's good enough. That's good. And so it's things that are more dynamic. They're not classical anymore. Baseball stats, chance of rain, How fast you drive to get here? No, that's something different. So I'm just saying, like, the things that kind of like change and they're different. They're not just cards, dice, and coins anymore. Does it make sense? So let's go. Same probability though. Selected over total. Law of large numbers. Empirical. Yeah, I don't know about that. All right, cool. Yay! There's a definition for you. Keep moving. So I don't remember having that as an important thing, but here we go. So stem and leaf plot. We remember doing this a while ago, right? It's been a long time now. It's like been a few weeks. But like when they're saying is that we got 1, 3, that's going to be what now? 13, and then 15, 17, 18, 18, that kind of thing. So like I could list them all out. It would take a while, but you kind of see what I'm getting at there. If a team is selected at random, find the probability of at least 34. 34 would be the least. Okay? Like we need more than 34 touchdowns, basically. Yep, exactly. Right here is that cutoff line, and then I would start like counting this way, basically, right? And I'm going to actually select everything that I got. Notice that this 9 is still here, yeah? And I got all these guys. Count the what? Yes, because those are different teams. So, like, we got 37 here, 37 for this one, 37 for that one. Yep, yep. And then we got these guys right here, and even this little guy down there. Okay. So, what's the probability of all this? So now I got to count them. So here we go. 1, 2, 3, 4. Oh, thank you. 37 selected. What's my total then? Okay, 38, 39, 40, 41, 42, 43, 44. Right? Help me out. Is it 50? No. Oh, no. Okay, yeah, 38, 39, 40, 41, 42, 43. Is it 60 or 62? Y'all count for me. What? I don't know. Y'all count. I don't know. 63. I'll take it. It don't matter. It's just a workbook. But I mean, you on your homework, you need to count it. You know what I mean? So does that fraction reduce? I don't think so, but we should probably just check just in case. I put it in. I try the fraction action. It's the same. So it doesn't reduce any. You're done. Is that okay? So part B, it says, if a team is selected at random, find the probability of the team scoring between 40 and 50, inclusive. Okay, between 40 and 50. So 40s, all the 40s, and then including 50 would be that little guy right there. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Did you all get 17? All right, count everything else. No, it's 63. 17 is prime, I'm pretty sure, so I'm pretty sure it's not going to reduce down any. So cool. If a team scores at random, or okay, selected at random, is scored more than 76. Yeah, just the one right there, right? Because there is no 76s. So the best thing we got is 87. So one selected out of 63. You got it. There we go. Cool. Awesome. So far, so good. On the real homework, y'all can count. Sweet. That's called MATH, guys. Y'all are doing it right now. Hard break. Another one. So subjective probability is it's just guessing. It's just guessing. Let me give you a really awesome example or two, okay? 4 out of 5 dentists recommend Crest. That sounds awesome, don't it? Really like that one. Oh, yeah. So you go to the doctor, and he says, well, you only got a 60% chance of living. You're like, 60%? Did you just pull that out of your pocket or something? And so, like, if you go in he goes to Wikipedia to find this stuff out. So you went to Wikipedia, he found 60, but the actual number is 59.38261%. I'm just making a point here is that he's just kind of guessing and throwing it out there. Okay. Are y'all seeing what I'm saying? Y'all have more than 60% chance of living. I'm just telling you. Okay. Don't worry. I'm not a doctor. I'm just a mister. Okay, good. Glad we got that. So classify this and that. Over the 8 seasons, a baseball player hit a home run 6% of his at bats. I don't know much about baseball, but there's some numbers. Is that subjective? Is that just guessing? No. So those are wrong. Is it classical? Is it something like cards, dice, coins? No. Empirical? Is it something that can change over time? Yeah, that makes sense. Charts, data, stuff like that. So it's going to be one of these guys. So because the probability is based on observations from experiments, or because it's a result of an estimate. Is it estimate? No, it's like actual experiment things. They were going through and checking it and counting it up and stuff. Yeah. Okay, cool. Oh, that was it? I just wanted more, man. I wanted 4 out of 5 dentists recommend Crest. So, whatever. I'm not getting paid for that. It's all about Colgate. Any questions? Great. Let's move on. Compliment rule. Compliment. Y'all give me an English that you think of when I say compliment. What's another English? Like an antonym. Is that what they would call it? No, synonym. Thank you. Not antonym. Synonym. It's one of them things. Compliment. What's another one? But in mathy land. Okay, fine, I'll do it. Opposites. Complement each other, you know what I mean? Yeah? No, you never heard of this. Yeah, opposites attract. Exactly. You complement each other and stuff. It's not like, oh yes, hello, good morning. No. Like, yeah, it's like opposites to one another. So you got like dark side, light side, and stuff like that. And oh, that's probably too far. I'm sorry, bro. I was playing. Opposites of one another. Opposites. So let's do the math for it, and it's very simple. The probability would be 1 minus the the other thing, the other stuff. I don't know. So here's an idea. So what if I had 40%? The opposite would be 60%. Oh, I know. Rain, not rain. Yeah. If it rains today, 40%, 60% not rain. 20% chance of winning the lotto, 80% chance of not winning the lotto. Right? Making sense? Opposites. Compliment. Okay, sorry. But you are looking very good today. Oh, yes. Thank you, Chad. Yes. I did not know y'all were thinking that kind of compliment. Sorry. Just too much math brain up here. Well, yeah, but like, give me English words, Okay. My bad. Anyway, so opposites. So from the frequency distribution, what's the probability of selecting something that's not 18 to 22? And so 18 to 22 is these guys right here, yeah? But they're saying not those guys. So I want to select everything else, right? Select everything else, and then we're going to go and find it. You add them all up and you get the answer. Yep. Now, and that's the point. You got it. The thing is that this is like taking forever all of a sudden, right? As if we like don't have the time. But where is a much faster way? You just got to like wait for 1 second while I do it the long way. Okay, there we go. Let's do a decimal today. Just make it fun. There we go. Are y'all okay with the long way? No, let's not do it then. Because the easier way is to say, well, let's take what we have right here, and we're going to 1 minus it. So the 156 over the 975, 1 minus, and then we're done. So 156 over the 975, same thing, right? And it's supposed to be faster. Okay. Can you do either way? Good. Okay. Cool. Okay. It is cold in here, right? Who's cold in here? Cold? Yeah. Oh, I know. You look cold. Woohoo! Phones collected from a conference are labeled 1 through 40. Okay. What is the probability of a conference speaker who will choose not a multiple of 6? Not a multiple of 6. Can we find out what the multiples of 6 are first? Help me with the 6s. 6. I'm trying. Oh, and that's the point, right? It stops at 40, yeah? And so 36 would be the last number. So I'm saying not one of these guys, yeah? And so what if I went and found out what the probability is of those guys, and then just opposite, right? And so how many would I have selected? 6 out of 40. And so that's like not what I want. What I rather would say is 1 minus this amount, okay? So let me do this, 2 different things. So 6 out of 40. Let's just say that I had 15%. So now I'm going to say 1 minus the 15% is, what's opposite of 15? Yeah, 85. Yep, you got it. And so you can do it either way. 85, fractions, whatever it is. Oh, it says simplify fraction. Look at that. Okay. There we go. Yay, Desmos. 17 over 20. I'll box it in 3 times because it's so important, apparently. Cool? Okay. Yay. That's not too bad. Scrolling on. Scrolling. Another hard break. So we got to learn some definitions. Mutually exclusive. Mutually exclusive. They cannot occur at the same time. Cannot occur at the same time. And you can see right here it says mutually exclusive. Notice that there's no interconnection. Okay. So I'm going to give you some. I'm going to give you some stuff here. Cannot occur at the same time. Can you drive a car and fly in a plane at the same time? No. Unless the car went with you. Okay. See, you're going to find these little things there, okay? Okay, here's another one. Can you chew bubblegum and a hamburger at the same time? Challenge accepted. So, and here's one more that I think is just hilarious. Can you be underwater and whistle? I know. I've heard that there's a law in Tennessee, I think it might be Tennessee, where you cannot whistle underwater. I know, it's so weird. So, anyways, they cannot occur at the same time. You get me? So then when it says not mutually exclusive, there means that there's some kind of intersection in there, okay? So I guess that would be the bubblegum and hamburger, maybe? Got wide cheeks, bro. Wide cheeks. So let's do this. Randomly selecting someone who owns a car, randomly selecting a married male. Are they mutually exclusive? No, they're definitely not. You can have a married male who is also owning a car. So no, because the events cannot occur at the same time, or no, because they can occur at the same time. They can, yeah. I'm going to fill it in like a Scantron. You're not using number 2 pencil. It's like, are there number 5 pencils? What's going on? Good? Okay. Some more. Actually, yeah, they're wanting us to fill this in. Oh my gosh, is that this question? Okay. Time out for a little mini second here. Your homework sometimes is called annoying. Yeah, it's just annoying. This is going to be one of those weird things where you have to like slide little pieces in and make sure that it's all in the right place and stuff. Just bear with it, bro. Just get through it, man. It's going to be okay. We got this together. Or you got this. I'll just, you're going to be at your house and be at my house. So here we go. Consider the Venn diagram. This is a Venn diagram. Welcome. We got cities who are Austin, Charlotte, Chicago, Duluth, Minnesota. Okay, the problem is there's 2 C's, and that kind of throws me off. And they're both CH's. Okay, who's gonna get the E? Is it Charlotte or is Chicago gonna get an O? Which one? Charlotte's an E or Chicago an O? Help me out, guys. Which one? Charlotte's an E. Then we got Austin. And we got Chicago. We got Duluth, Minneapolis, New York, Seattle. Are those unique letters? Unique letters? Okay, so now I can start moving around. Good. All right, so event A, you can see A right there and B right here. So the city has positive population growth. So basically, I'm going to erase those and write what they actually are so I can, know what I'm doing here. So this is population growth. And the other one says positive economic growth. So this is economics. Yeah, that didn't really work out there. Let me try again. Econ. There you go. So population, econ. Can you have a city who's growing in population and in economics? Yes. Can you have one that's not growing in population and also not in economics? Could be. And they would be outside of the zone entirely, somewhere out here. So let's go through this. Austin, Charlotte, E, that's an E, Charlotte, Chicago, New York, Seattle are reported to have positive population growth. So I need to put them in there now. And this is just me. What I'm going to do, like it's a 2-part problem here. So Austin, Charlotte, Chicago, New York, Seattle, they're all in the population box right now, okay? I'll move them around later if I need to, okay? Minneapolis, New York, Seattle are reported to have positive economic growth. Okay, so that's Minneapolis, New York, and Seattle. But now I'm feeling like there's some that are overlapping now, right? Y'all see the overlapping ones? There you go. So what I'm going to do, this is just, how Chad thinks about it. I'm going to erase both of them, and I'm going to put them in the middle, okay? So both of these guys get out, and New York, Seattle go in the middle now, okay? It's whenever you got a lot of things going on, sometimes I just don't know what goes where. I just want to start putting them separately and slowly moving them to the right place. Is that okay? Okay. Okay, so we did that. Duluth is neither. So where would Duluth go? Yeah, way out over here, Duluth. Yep, far away. I think that's it. Now, it says determine if the events are mutually exclusive. Are they mutually exclusive? No, because we have some intersection between them, right? So I'm going to say no. We have some intersection. Yes. Yes. Totally. I would go with what you're saying. That reality says there could be something. Yes, I would go with what you say. Yep, definitely. I know, and I can't promise the homework one way or another, but I will say I would go with you. And if you got it wrong on a test, I'm going to be giving you points. All right. And it's being recorded right now. All right. Another one. So the same kind of style. Any questions on this one? Rock and roll. Let's keep going. So we got event A is they support new walking trail. So we're going to do a walk for this one. And then this says a new roundabout. So I'm going to go round. We got walk and round. Okay. We got B, E, J, M, S. Unique letters. We're good to go. So Ben, Jerome, and Max all state that they are for the new walking trail. Whoa. But not the roundabout. You see that? Okay, so they're for the walking, but not the roundabout. They are definitely for sure in this zone right here. Okay, for sure. They ain't moving. They said they're not for the roundabout. Elizabeth says she supports a new roundabout, but not the walking trail. So Elizabeth's definitely over here for sure. Cool? Okay, so far so good. Shelby says she supports neither of them. Where would Shelby go? On the outside. You're far away out here. Place the names appropriate. There we go. Are they mutually exclusive? And in reality, they're not. It's a good question. See, this came up, but for the place the names in the appropriate and then determine if the events are this. You know what? I'm just going to put a big old question mark right there. Ha 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 ha. I know. I know. Well, here, you know what's interesting? I didn't actually read. So maybe I should read. So they're asked whether they support a new walking trail or a new roundabout in their neighborhood. Are they mutually exclusive? I don't know because maybe they only have so much money for one or not the other. Maybe they're taking up the exact same spot, right? I don't know what a roundabout would be, but definitely a walking trail takes up space. So I'm going to put a big question mark just for you. But if you wanted to know what my what the homework wants, the web, not my math lab, not WebAssign, Newton. See, I use all these different programs. Sorry, they're gonna probably say, are they mutually exclusive? You'd say yes. Dot dot dot. Okay, cool. Now it's written down. But I totally still agree with you. Moving on. I guess this is more of the same kind of stuff here. Pregnant women have the option of being scanned for this. If a mother or a father have this gene, then they got that. 3 different events are all these things here. So mother or father carries the gene, father carries the gene, baby at risk. Okay, so they're wanting to know what's mutually exclusive or not. We're just like selecting whatever's true. So A and B are mutually exclusive. So father or mother carries a gene, father carries a gene. Could that never happen? It could happen the same, right? If the father has a gene, then they kind of like both events actually happen. So they are mutually exclusive. That would be false, right? False. B and C are mutually exclusive. So father carries a gene, baby at risk. Could they never happen together? No, they would happen together, right? Father has it, baby at risk. So that doesn't make sense. Okay. A and C are not mutually exclusive. So if they carry the gene, then the baby's at risk. That's definitely a thing that's not mutually exclusive. That could happen. And then A and C are mutually exclusive. So father and mother carry the gene. Oh, well, that's literally the opposite of what we just said. There you go. So I'm going to look that one over for real quick because I'm wondering about it myself. We did that. Of course, it's not in my old book. So the only ones that I'm kind of wondering at all about, I don't actually have in my book. So sorry. Good enough though. Are y'all understanding kind of what I'm getting at? Keep cruising. Subway trains and transit buses operate on different days and cannot occur together at the same time. Cannot occur at the same time. Do you see that? Okay. So then, a train X is delayed, subway train is on time, and then the transit bus is delayed. Okay, so subway trains and transit buses operate different days and cannot occur at the same time. Okay, so B and C are mutually exclusive. So, yep, I'm sorry, did the wrong one there. B and C. Are these mutually exclusive? Totally never can happen at the same time. It's on time and this one's delayed? Never run at the same time. So this is mutually exclusive? Yes. B and A and B are mutually exclusive. So it's either delayed or it's on time. Can you be both delayed and on time at the same time? No. So they're mutually exclusive? Yes. Cannot occur at the same time. A and C are not mutually exclusive. So subway train is delayed, and then at the same time, we can have a transit bus that's also delayed. Yeah, it's not true. So they can't occur at the same time. So they're not. So they are mutually exclusive. So there can't be that. I know it's like not, right? Hey. And then we just said that it's not mutually exclusive, so it must be this guy is mutually exclusive. Okay. Whew. I hear a lot of other people leaving. Does that mean it's our queue as well? Oh, no, bro. Hold up. We're having such a good roll time here. We got this. We got this. I know I said it out loud, but I shouldn't have. So, hard break, brand new thing here. This is a really nice little formula, but let me just summarize this for you here. When you see the word and, we're supposed to what again? Okay, and means multiply, and the word or means to add. And that's what they're trying to get out right here with that small portion. If you have or, then you're going to add, okay? Now, there's a little bit more to it up here. They got this other stuff, and I'm going to just demonstrate what that looks like without a formula. Say we go back to the Venn diagram for a little bit, and I'm going to say I want the probability A or B, okay, A or B. And so I'm going to have all of the A. Here we go. Okay, cool, cool. I'm going to have all of the B. Yeah, did you see it? Did you see it? But didn't I select that part in the middle twice? Didn't I select it twice? Is that a good thing? No, we shouldn't be selecting it twice. And so this little part here is saying minus just the inside proportion once. Okay, in a way, let me try to redraw this for you. So I'm going to try to draw this really big. They're saying select all of A, and then select all of B, but then never mind, go back and erase that. Go back and erase. Only make sure that you select the inside of that one time. So I'll just select it one time here. There we go. There we go. I know, it's so weird. Or means add. Let's keep going. So the probability of students selling brownies is 0.2, 20%. Probability of selling root beer floats is 40, and the probability of selling this and that is 1%. What's the probability of selling or? So they're using that formula. They're saying the probability of the or is the probability of A plus the probability of the B plus the probability of the and. Okay, that's that. Oh, I'm sorry, not plus, minus. Oopsie, minus. Okay, so I'm just going to fill in the pieces. What's the probability of A? Give me, what is A supposed to be? What's the A event? Brownies. Okay, so we got brownies. So if brownies is event A, what's event B? Root beer float. There you go. And what's the and? Both. 0.01. You see the math that I'm doing, right? 0.2, 0.4 minus 0.01. There's my answer. Okay, so I just used the formula straight up. Awesome. Cool? Good? Good? Okay, let's do another one. Anne wants to buy a Corvette or a Porsche or both. But, oh no, never mind. She doesn't have enough money for that. So she has this much probability for the Corvette, this much for the Porsche. She can't have both. So what would I do with this or? How do I find the or amount? Or means what? Add. Or means add. And it's like a simple add, right? You get this one or that one. I often think of like the game show stuff. I haven't watched any of this in like forevers, but they got game shows where they're like, okay, well, you just won the prize. You get to choose the car, or you could choose the boat. And I'm standing there as a mathematician. I say, I'll take both, because or means. And then they're gonna be like, no, Chad, you can't be a mathematician here, because see, or could mean the and part as well. Just saying. Yes, indeed, that's right. In a way, it's kind of funny. What's the probability of her buying both a Corvette and a Porsche? What's the probability? Yeah, minus what? 0, right? 0, because 0 chance of getting both, right? She doesn't have enough money for that. Let's do this last one here, and then it looks like we're gonna start doing graphs and stuff. I don't want to go too far with you guys, but I do want to keep going. Let's just see where we are. Hold on. If we, oh, look, we're so near the end. We only got a page left. Is that okay? Y'all cool with this? I mean, we got 20 minutes left in the class. Okay, I know. I mean, we've been doing so good today, but like, let's just finish up the section. Electric company has to track on-time payments or late payments for each customer. Probability of on time is this much. Probability of late or on time is this much. What's the probability of being late? So it's kind of weird. Can you be both late and on time at the same time? No. So they're mutually exclusive. You can't have the both. Yes, exactly. So then that's exactly right. The or amount is my total, really. That's my or. And so then I got basically the or amount is my A plus my B, right? And so my A was the 55, and I'm looking for the late, the B. So you're going to subtract for this one, right? So here we go. Subtract and calculator. How much would that be? It would be calculator, Chad. Yeah, I know. Yay! There we go. Are y'all understanding me subtracting in this particular case? I have to kind of like lay it out. I got or is A plus B, and so then I got to like find that formula, I guess. There you go. Okay, if you say so, Chad. Thanks. I'm Chad, by the way. Hello. Hey, keep referring to this guy. What's going on? So looking at the chart here, it says randomly selecting a 30 to 39. 30 to 39, is that right here? So then what do I do to these two probabilities? You add them up, 37.5 plus the 24.5. Let's do it. 37.5, 24.5. Oh, there you go, 62. 62%. I don't know how they're actually wanting it. Let's just say they want decimals. You would do this. But if they say percentage, then you do percentage. Easy enough. Not 30 to 39. Like these are polar opposites, right? So then how would I get that amount? Subtract what? 1 from it. Subtract 1 or 100%, right? 38? 38? 38%. Okay. And then finally it says less than 45. That would be like all of this stuff, isn't it? So would it be easier, instead of adding it all up, which you totally could, wouldn't it be easier just to say the opposite of this guy? Yep, 100% minus the 3.7, right? 96.3. Cool. Cool. So that makes it a little bit easier. Again, you could add them all up. I'm okay with that. And I'll see you in 5 minutes. But I think it's quicker. I'm just making that joke. It wouldn't take you 5 minutes. I do that in algebra land, though. I'm like, okay, what should we do? Quadratic formula. Okay, I'll see you all in 5 minutes. In the meantime. Okay. Good? Okay, last page, right? This is the last page? Last page. We're almost there. So, blood banks, catalog number of bloods, and stuff like that. Okay, cool. So we got all this stuff. Now, find the probability of a donor having type B or type AB. So I want all the type Bs and all the type ABs. Yep. So I'm looking at these individuals this time. So I would actually add up every single one of these together. Now, this takes a while. Don't they give you like the little subtotals? And so, yeah, you could do this. Here, there's my grand total. Grand total. But you can definitely do the subtotals also. Makes it way faster. But you know me, I'm going to go to slow way first. So, yeah, we got 0.149, I guess. The quicker version for that is, again, you could just say two subtotals, you add them up, and then you divide it by that number there, right? Straightforward. Could you do that instead? Yeah, sure. Do you want to do that instead? Maybe. Find the probability of O or positive. Okay, so hold on. Let me get another color. So O would be these folks. Positive is, yeah, all these guys right here, exactly. So that's a lot to add up, right? If you say so. So, yeah, there is what we could do. We could say all this 344 in the top, and then we're simply adding up this 28, right? So that's one way to do it. You know me, I'm going to try to be, a math teacher, I guess, and I'm going to do the slow method because, well, I got to do the slow method. I feel bad if I don't. So add it all up, divide by the 409, and then we're good there. But yeah, you can definitely use subtotals as well. Here we go. I got to be the proper math teacher once in a while, right? Can't go like using shortcuts and stuff. Right. If they got selected, cool. I don't want to count them twice. Very good. Yep. Because that would skew my numbers, right? There would be like a lot more of these guys than not. Very good. Very good. So, not too bad there. Definitely different options there. I also want to emphasize, and I'm going to do this a lot more next time, but there is this like cutoff line that I'm using for actual hard data versus totals, like subtotals and stuff. The actual numbers are up here. Notice I never actually select a subtotal. I was just kind of like mentioning it. I always select the actual numbers up there. All right, cool. Is this the last stuff down here? Last two problems. So we got A is this, B is that, OR is that, find A and B. So let me just remind you of the formula. So OR is A plus B minus the AND, okay? I've really simplified it a lot. So what goes in the OR position? What number? 0.67, very good. What's A? 0.5, awesome. B is? And then I'm looking for the AND, right? That's what they're looking for. It's like I need to solve for the AND in a way. How can I do that? What would you do? Have you done algebra in a while? Subtract them. Yep, start subtracting them to the other side. Exactly. Subtract this over here as well. And then it's going to be a negative number, but you would just say, you know, whatever number we got here. So 0.67 minus the 0.5 minus the 0.3. So we're saying that negative 0.13 is a negative AND. So yeah, 0.13. Is that making sense? Okay. Is that making change? That's just keys. There's just keys. Okay, here we go again. My OR is equal to A plus B minus the AND. I'm just following that same formula. What goes in here for OR? Yep, 0.98. My A is A. 0.6. B, I don't know B. Leave B alone. And there we go. Solve for B. So what do I do with this 0.6? Subtract it. But what do I do with the 0.02? There you go. You add it to the other side. 0.02. And so now I got B is equal to, calculator, 0.98 minus 0.6 plus the 0.02. There we go. We did it. And we finished that section. Yay, I feel so good. Thank you, guys. Okay, any questions? Y'all good? Thank you, guys. Peace out, homies. Y'all have a great day.